All right, while we were waiting for that to get saved, we were discussing this. We know that the acceleration is what's given. We know the initial velocity is 5 miles per hour, but it is accelerating from there, and we know its acceleration is miles per hour per second for the first 8 seconds. We have to now determine how fast it is. Like I said, the hardest part is determining, well, what does how fast mean? And you told me it means velocity, which means if I've got acceleration, how do you get to velocity? Derivative, antiderivative, take the antiderivative twice, take the derivative twice, antiderivative once. Very good, if we have to get to velocity. And so we are going to take the antiderivative. We'll look something like that. And we know that in here is 2.4 t dt from 0 to 8. Okay. And of course you have the calculator means of doing that one, or you could just figure out the triangle that would form, but either way. Because 2.4t is a line. Or you could use the calculator, either way. And what'd you get for just this part? Is 76.8 correct for this part? Yes, it is. But let's check the label. Okay, let's just check the label before we add the 5 that you know about. The label of this function is miles per hour per second. So we'll do it this way. Miles per hour per second. How is that going to make sense for you guys? We'll just do it this way. Per second. It'll be easier for you to see it that way. Do you agree that's what that says for acceleration, miles per hour per second? This 0 and 8 is seconds. Do you agree with that? So I'm basically multiplying it by seconds because I'm figuring out that that's how many seconds. So what happens with the seconds? They cancel. So the label of this answer is miles per hour. Does that make sense? For velocity to be miles per hour? Yeah, that makes sense. But, yeah, exactly. That's one way that you can measure velocity, right? We do have to add, because this 76.8 is just the displacement. That's how much the velocity has changed, not necessarily the total velocity. We do have to add the 5 miles per hour we started with, which is from right here. And so we get 81.8 miles per hour. Now, I noticed one of you having a relatively interesting look on your face when we started this problem. Could this one have been done by hand relatively easily? Could you have taken that antiderivative by hand? Yeah. Let's do that and see if we get the same answer. Oh, okay. So what is the antiderivative of 2.4t? Well, it's 2.4t squared over 2 plus some constant, right? If we're not doing the 0 and the 8, which becomes 1.2 t squared, and we know the constant is 5, say. So plus 5. Do you agree in general that is the velocity equation then for this problem? And then why don't you just put in 8? Because that's really what you just did with that other problem. So if you just substitute in 8, just take a wild guess what you're going to get when you take 8 squared and take it times 1.2. 76.8? Yeah, wild guess on that one. And then add the 5. Are you going to get the same 81.8? Yeah, it's going to work out the same. Okay. Well, if that's not why you had the word face, could you maybe explain why you had the word?
I just thought you could just plug the 8 into the 2.4t.
Okay, if I plug 8 into the acceleration, that would tell me the acceleration at time 8. Okay, that's all it would tell you. Which is actually a considerable acceleration if you think about it. That's pretty big.
Never got tired of teaching. I don't think you always start teaching physics.
How far did the car travel during those 8 seconds? Would you expect it traveled very far in 8 seconds? We know it was going how fast? But it would have only gone 81.8 at 8 seconds. That's the only time it was going that fast. So did it start going that fast? No, it started going 5 miles an hour. So you expecting this to go a very long distance in only 8 seconds? Probably not. So now how are we going to get total distance? How did we get it before? Yeah, absolute value of all of that, exactly. Or you could, but this is how far. How far? Yeah, which are we talking about? Are we talking about position, velocity, acceleration? Position. Wait a minute. We're talking position. Well, we just found out, and I just showed you that velocity's function could be written as 1.2 t squared plus 5, correct? I showed you that. And what was the label on this one, just out of curiosity, was miles per hour, correct? That is because the seconds canceled, right? So, well, let's face it, is this ever going to be negative? Do I really have to worry about the absolute value on this particular one? No, but if you want to keep that pattern, that's fine. So why don't you go ahead and basically find, because if I take the antiderivative of that, it will give me position, so go ahead. If you want to keep the absolute values in there, you're fine, because it's probably a good habit. Again, I think you're pretty good at using the calculators by now. Yes, you can just take the antiderivative again, yep, and put in the 8 if you would like. Either way will work. There still would be a plus c, and we would consider the initial position being 0 if you wanted to do it that way. And some of you may be typing it in and looking at your answer and typing it in again because you think you did it wrong. What are you getting for an answer? 244.8? Really? Just went 244.8 miles in 8 seconds? That's a nice car. Just take a break, go back, and remember what I did. Oops, I must have erased it. This was miles per hour per second, right? And then I took it times seconds because that's what this was, right? And then the seconds canceled, agreed? So this answer is actually miles per hour times seconds. Is that a label we normally use when talking about how far something goes? Not normally. So maybe let me write it this way. We have to convert to something we do know. That's 248 miles in 1 hour times 1 second. Because there's your hours, and there your seconds are in there now, correct? And that's the only way I can do it, is take it times 1 and times 1. In, I believe, chemistry or perhaps physics, you do a lot of canceling of labels. Okay? We're going to have to cancel labels, which means what has to be on top for the hours to go away on the bottom? Hours. And what has to go on the bottom for me to cancel out the seconds that are on top? So we have to somehow relate those. 1 hour is how many seconds? $3,600. Thank you. Take 60 times 60. Now do all the labels cancel and leave me with what I want? Does it leave me with miles? Yes, it does. To take 1 times 244.8 times 1 and divide it by 3,600. Do you agree that 3,600 seconds in 1 hour? This is your conversion factor. Miles is the only thing left, right? So basically take 244.8 and divide it by 3,600. That'll make a much more sense. And what do we get? 0.068? Does that make a little bit more sense than 8 seconds to go that far? Then 244 miles in 8 seconds? Nope. But you got to realize they didn't get to 81 miles an hour until 8 seconds were up. Well, the acceleration at that 8 seconds was pretty high. It was about 30 miles per hour, yeah. So you have to watch out for labels. Would it have been way easier if this would have just been hours here? If this was hours, well, the miles per hour and the hours would have canceled. It would have just been 244.8 miles. But it was miles per hour and then times seconds. That's a problem. Any questions? Because we went from 0 to 8 seconds again. Because we did seconds right here. The first one, because this one right here is miles per hour per second. That's what acceleration is always. It's always measured in 2 time frames. Normally we try and keep the time frames the same though, but this one I did not.